Hello there, this is Makuto, and today we're diving into the fascinating world of 3D printing. A world where the boundaries between the digital and physical blur, where you can bring your ideas to life quite literally at the click of a button. In essence, 3D printing, or additive manufacturing as it's technically known, is a process of creating three-dimensional objects from a digital file. Layer by layer, material is deposited until the object takes shape. Now, this isn't just some whimsical tech fantasy, it's very real. And it's being used effectively across multiple fields, from creating intricate parts for manufacturing, to bioprinting tissues in medicine, even to constructing buildings and architecture. The capabilities of 3D printing are truly mind-boggling. But while 3D printing is indeed impressive, it's not without its limitations. Let's begin by understanding the technical limitations that hinder the full potential of 3D printing. Firstly, the range of materials that can be used for 3D printing is currently quite limited. While plastics, ceramics, and some metals can be used, many other materials like fabric or glass still pose a significant challenge. For instance, imagine wanting to print a smartphone. While we could potentially print the plastic casing, we couldn't print the glass screen, the electronic components, or the battery. Next, the time it takes to 3D print objects can be a major drawback. Even a small object can take hours to print, and larger, more complex structures can take days or even weeks. This is because the 3D printer has to build the object layer by layer, and each layer has to dry or harden before the next one can be added. This process is painstakingly slow compared to traditional manufacturing methods. Now let's talk about the cost. 3D printing, especially with metals and other high-quality materials, can be quite expensive. The cost of the printer itself, the cost of the materials, and the electricity used can all add up. Plus, if a print fails, which is not uncommon, the wasted material can increase costs even further. This makes 3D printing less economically viable for mass production. Finally, precision can sometimes be an issue. While 3D printers can be incredibly precise, they are not perfect. Small flaws or errors in the printing process can lead to defects in the final product. This is particularly problematic when printing parts for industries where precision is crucial, such as aerospace or medical devices. So, to sum up, while 3D printing is a revolutionary technology, it still has its limitations. The range of materials, the time it takes, the cost, and the lack of absolute precision are all technical hurdles that need to be overcome. These technical issues are a big reason why we can't 3D print everything yet. Beyond technical hurdles, there are also practical limitations that keep 3D printing from being a one-size-fits-all solution. Let's delve into this a bit more. One of the significant practical limitations is the absence of standardization and regulation. This can lead to serious quality and safety concerns. Imagine, for instance, 3D printing a car part. Without stringent standards, how can we ensure that the part will function as intended or that it won't fail under stress? And what about medical applications? An improperly printed prosthetic or medical tool could have dire consequences. Next, let's talk about the environmental impact. While 3D printing has the potential to reduce waste by creating only what's needed, the reality isn't quite so rosy. The process often uses plastics or other materials that are not biodegradable, adding to our growing waste problem. Additionally, the energy requirements for 3D printers can be substantial, further increasing their carbon footprint. And then there's the issue of cost-effectiveness. 3D printing is fantastic for prototyping or creating bespoke items, but when it comes to mass production, it can't compete with traditional manufacturing methods. A 3D printer takes the same amount of time to produce one item as it does to produce 100. In contrast, once a traditional manufacturing line is set up, it can churn out products at a vastly superior rate. This makes 3D printing less economical for many products. Finally, there's the limitation of materials. While we've made significant strides in the types of materials we can print with, we're still a long way off from being able to print anything and everything. Many materials, especially complex ones like multi-component alloys or specific types of glass, remain beyond our reach. So, while 3D printing has its benefits, it's not always the best tool for the job. But who knows what the future holds? Technology is always advancing, and perhaps one day we'll see these limitations overcome. For now, though, it's essential to understand these practical boundaries and consider them when deciding whether to use 3D printing. Despite these limitations, the future of 3D printing is promising. Imagine a world where the constraints we've discussed become mere footnotes in the history of this remarkable technology. It's within our grasp. It starts with the evolution of materials. Scientists are already hard at work, developing new, printable substances that could exceed the limitations of what we currently use. It's not just about plastic anymore. We're talking metals, ceramics, even human tissue. The possibilities are as varied as they are exciting. Next, we have the advancement in 3D printing technology itself. We're moving towards faster, more precise printers that can handle complex designs with ease. This could potentially revolutionize industries from healthcare to aerospace. Then there's the question of quality and safety. As with any technology, regulation is key. It's up to us to ensure that what we print meets the highest standards. So while we can't 3D print everything today, who knows what the future holds? To summarize, 3D printing is a powerful technology with a lot of potential, but it's not a magic bullet that can solve all manufacturing needs. We've seen how it's revolutionizing industries, offering unprecedented flexibility in design and production. But remember, it also has its limitations. Our journey today took us through the technical bottlenecks of 3D printing, the challenges with materials, precision, and speed. We also delved into its practical constraints, touching on cost-effectiveness, scalability, and regulatory hurdles. But let's not lose sight of the future. With advancements in technology, we're inching closer to overcoming these obstacles. The future of 3D printing looks promising, with immense potential to transform our world in ways we can't even imagine yet. Thank you for watching. If you found this video interesting, please give it a thumbs up, leave a comment, and don't forget to subscribe for more tech insights from Makuto. Until next time, keep exploring the world of technology.